Lead to nitrate. We've seen that a few times already. All right, all nitrates are, well, it tells you the reactants are all solutions. So lead to nitrate is NO3 with a 1 negative charge, and the lead is a 2 positive charge, and crisscross that down. We're going to have 2 nitrates, which is the reason for the parenthesis. AQ, letting everyone know that's soluble. Sulfuric acid is H2, 2 protons to that sulfate, SO4. That's given. And acids are going to be in solution of water. All right, that's going to give us. Let's switch these cations. I'm going to write the soluble one first because I don't know. I just feel like doing it. All right, so that's nitrates are going to be soluble. So I'll write the H with the NO3. That's nitric acid. Well, it's going to be AQ. Right? No need to crisscross the charges because one positive, one negative, they're going to cancel out. And the lead is going to end up with the sulfate, which is going to be a precipitate. This is lead 2, and sulfate is also a 2 negative charge, so they're going to cancel out. S4 precipitate. Okay, let's balance this. We have 2 hydrogens, just to see what we have multiple of. So I'm going to put 2 there. That's going to balance. It's going to balance everything, right? All right, 2, 2, 1, 1, 1, 1, 2, 2. Okay. 1. Whoops. All right, so let's write the complete ionic equation. So everywhere you see AQ, we're going to free them up, dissociate them with their charges. All right, lead in this case is a 2 positive charge in solution, and there's bring that to the front because that's how we quantify these. All right, we have 2 nitrates, NO3, the 1 negative charge, AQ. Plus, we have 2 protons. All right, bring that 2 out to the front. These are all in aqueous solution. And then we have 1 sulfate. Sulfates are 2 negative polyatomic ions, and that's also AQ. All right, I'm going to write the products on a staggered line here, but if I had space, I would just keep going. All right, also soluble, so nitric acid is 2 protons, AQ, plus, all right, distribute there, 2 NO3s, 1 negative charge, AQ, and this is our precipitate, so that's not soluble. We're going to write that the way it is. All right, let's cancel out the spectators. They're going to be the ones not participating. So your nitrates don't participate and your protons don't participate. So let's rewrite what's left. That's going to give us your lead, 2 positive lead 2 ions reacting with your sulfate ions, and that's going to give us lead 2 sulfate. All right, so there's your net ionic equation. Charges and mass conserved or balanced. All right, so that's A. So I started with brown, turned into green. So I'm going to run out of colors. I'm just going to keep going with this format. All right. Lead acetate and hydrochloric acid. All soluble. All right, this is lead 2. Is that what it said? Yeah, lead 2. All right, acetate is your polyatomic ion, and it has a 1 negative charge, so we're going to need a parentheses here. And this 1 negative charge and this 2 positive charge, they're going to crisscross, and we're going to have 2 acetate ions dissolved in solution. That's soluble. All acetates are soluble. And I believe it said hydrochloric acid. So that's HCl, soluble. All right, let's switch these cations. I'm going to write the soluble one first. It's just the way I've been doing it. So all acetates are soluble, so that's going to go with, oh, we don't need a parenthesis here. I'm going to put it here because it could look a little confusing without it. So all right, so the 1 negative and the 1 positive are going to cancel out. All acetates are soluble. All right, I already ran out of room. Okay, so the chlorides are generally, we've seen this one a couple times already, are generally soluble, but lead is an exception. So that's going to be PbCl2 because it's lead 2. Here, let me show you. So chlorides are a 1 negative anion, and lead 2 is a 2 positive cation. So we'll switch those, and that's our precipitate. All right, time to write time to balance this. Let me pick a slightly different shade. All right, we got 2 acetates on the reactant side and only 1 on the product side. Let me put a 2 there. That means we have 2 hydrogens on the right, and then 2 on the left. So put a 2 there, and that should do it. All right, we have 2 chlorines and 2 on. All right, so let's just rewrite all of this stuff where the ions are free to float around. All right, the lead has a 2 positive charge, and we're going to put AQ there because it's not in this compound. When it's dissolved in water, it's just free ions. And then hey, let's bring that quantity up to the front. All right, so 2 acetates. They have a 1 negative charge, so don't forget your charges. Don't forget your AQs, and we have 2 protons. And we have 2 chloride anions. All right, don't forget to distribute. And that's going to give us, okay, 2 protons and 2 acetates. All right, I'm doing here, right there. Don't forget your plus signs. And then finally, our precipitate is lead 2 chloride. All right. At some point, you're gonna think, well, I can just skip this step because you're seeing patterns. But the question might ask you, oftentimes, write the complete ionic equation. So you can't just forget about this step. All right. The spectators are the ones that appear on both sides of the equation exactly the way it is. So, and they don't participate. So we're going to get rid of those spectators and rewrite what is left to get our final answer. So lead 2 positive ion is going to react with 2 moles of chloride anions, and that's going to result in lead 2 chloride, which is your precipitate. Balanced charges atoms. There it is. Moving on. Number 3, letter C. All right. Oh well, that's nice. They gave us the reactants. Okay, I see why they've been changing it up on you. So instead of giving you the Roman numerals, you're going to have to work backwards to get the charge of this iron. That's good. All right. So let me, I'm just going to copy this. Copy. All right. Let's do it. Let's predict the products. Let's just switch the cations. Okay, well, pause. What do you think is going to be the soluble one? Let's just write that first. It's the way we've been doing it. All right, well, alkali metals are going to be soluble, so I'm going to write the sodium one first. Sodium rewritten with oh, well, that's table salt. So you already know that that's soluble. Sodium chloride, AQ. And we're going to switch up. The iron is going to get a new partner. All right, so iron is going to be with phosphate. So now hold on for a second. We're not going to need that. What is the charge on iron? Iron can have multiple charges, but here's the hint. If you reverse crisscross, that 3 came from the charge on iron. So we know iron in this cation has a 3 positive charge, and the phosphate anions have a 3 negative charge. So they're gonna cancel out. Nice. I'm gonna rewrite this without that space in the. Okay, and that's your precipitate. Okay, if you look through our solubility rules, phosphates are generally insoluble. All right, so we are going to write. Let's balance this. Okay, you got 3 sodiums on the reactant side, and so I'm going to put a 3 there. That's going to give us 3 chlorides as well. So that's going to balance. That's good. That's it. 1, 1, 3, 1. 1, 1, 3, 1. So let's write the complete ionic equation. That's everywhere you see AQ. It's just going to be dissociated. All right, bring these quantities up to the front because we use coefficients. And don't forget the charges. Sodium has a 1 positive charge. Write AQ plus. Phosphate is PO4 with a 3 negative charge. AQ plus iron, in this case, is a 3 positive. We determined that from the reverse crisscrossing. All AQ, all dissolved in water. All right, bring that quantity up to the front. These are all separated. It's like this chlorine. If you put that 3 there, it's just like, it means it's a molecule. It's like clump. There's a bond there, and these are all these ionic compounds are all dissociated. It's just all freely floating around. So there's 3 moles of chloride ions. You could interpret that as. Okay, now let's do the products. We have 3 moles of sodium ions in solution, and then we also have distribute there. 3 moles of chloride ions in solution, and finally our precipitate is just going to get written the way it is without charges. Okay, let's cross out the spectators. All right, spectating, go home, spectating. All right, so rewrite what's left to get our final answer. That's going to be your phosphate. Ions in solution are going to react with the iron ions in solution to produce iron 3 phosphate. There's it. Answer. One more to go. We did that. I'm just going to copy this like I did. Control C. All right, let's stretch this out a little bit. Okay. All right. So let's switch these cations. We know all ammonium compounds are soluble, so I'm going to write that first. NH4. So that the new partner is going to be with nitrate, and they're both one charges, one positive and one negative, so no need for parentheses. All right, but we'll put AQ there, and then might run out of space. All right, sulfides are generally insoluble. All right, so cobalt. All right, what's the charge on cobalt? All right, 2. Use that subscript, reverse crisscross. All right, so cobalt is a 2 positive charge, and sulfide, sulfur, anion is going to have a 2 negative charge, and they're going to cancel out. So it's just C, little o, big S. All right, let's balance this. All right, we have 2 ammoniums on the left. We had 1, so I put a coefficient of 2 there. That also gives us 2 nitrates, which we have already on the reactant side, and we're balanced, 1, 1, 2, 1. All right, let's write the complete ionic equation. So everywhere we see the AQs, we're going to free them. So bring that quantity to the coefficient, because keeping it down there makes someone think that there's like bonded together, and they're not. So we have 2 moles of ammonium ions in solution, along with 1 mole of sulfide. Right, sulfur anions have 6 valence electrons, so they're going to gain 2. Remember that? So that's 2 negative. Cobalt is a 2 positive, because we determined that from that subscript there. And nitrate, there's 2 of them, 2 moles of them, you can say. So bring that quantity up to the coefficient spot. 2 NO3s, and nitrates are 1 negative charge, and AQ for solution. All right, now for the products, don't mess up, I'm almost done. 2 ammoniums, 1 positive charge, AQ, and then distribute there. There's also 2 moles of nitrate, and then the precipitate we're going to write just the way it is. Cross out the spectators. Nitrates are spectators, ammoniums are spectators. You know, it's kind of good that we did 4 in one video here, just because you're seeing it, the repetition here revealed. All right, write whatever's left. Those are your sulfide ions reacting with the cobalt cations to produce cobalt 2 sulfide precipitate. So there's our net ionic equation. Done. There's our solubility rules. All right, generally insoluble. What else did we do here? I think we did phosphates. All right, always soluble, pretty much. Your alkali metals, your nitrates, your ammoniums, your acetates,